Alright, so in this video, I will be discussing a project that I've been thinking about recently. In my endeavors to try and better understand WebAssembly, I've decided to create my own compiler that basically compiles WebAssembly text format into a WebAssembly executable. And so I'll be starting off by kind of going over this sample WebAssembly text format file, describing how it works a little bit, and then I'll go ahead and compile it and run it using wasm time. And wasm time is how I will basically, it's what I'll use as my source of truth to confirm that the compiler that I've written is correctly compiling the WebAssembly text into the WebAssembly binary format. But so first, we can go ahead and talk about what this file here is doing. So we basically are kind of just defining a module, which is kind of, just a unit of code that is able to be instantiated. And in it, we have three distinct functions. So our first one is called add2, we have another one called add4, and another called add3, and they all just add the number of inputs in their name. So this adds 2 numbers, adds 4 numbers, adds 3 numbers, and returns it. So here, the mental model that we use when thinking about WebAssembly text format is like a stack machine. So this first instruction here is basically getting the 0th input, which is specified here. So our function has 2 input parameters, each of which are 32-bit integers, and result, which is also a 32-bit integer. And here we are basically putting our first input onto the stack, then we're putting our second input onto the stack, and then lastly, we have our i32.add here, which is taking the top 2 elements on our stack and adding them together, and then that's what's on the top of our stack, and so then that's what is our result is. Here in add4, which is a little bit more complicated, we have 4 inputs, all of which are still i32s. We put each of them onto the stack respectively. We then add the first 2, which would be these right here. We then put the result onto the stack. So then we are doing it again, where since this is already the sum of these last 2 inputs, we're adding that sum to this input right here. And then in this final one, the top 2 elements on the stack, the top 2 items on the stack is the sum of these 3, which are then being added to this one. And at the end, we have basically the sum of all 4, and that's what's being thrown on the stack. So we can see now if we use wasm time, which is basically our WebAssembly binary runtime, we can go ahead and basically, well, first, why don't we go ahead and do cargo run. And I have this project nested in a silly way, so I need to do this first. Okay, and here we can see when we run, this is actually the binary that ends up being written to our executable file, which isn't human readable and thus isn't, suggests that we not open it. But we can then go ahead and do wasm time add4.wasm, and then -- invoke to specify what we want to invoke in it. And we can say add2 because that's the function, and then we can feed it 2 arguments. And as we can see, it spits out 3. Similarly, we can do the exact same thing, but instead of calling add2, let's call add4, and we can throw these guys in. And we get 2 + 3 + 3 + 4, which is indeed 12. Just so that we can see that this is compiling correctly. If we wanted to, we could go ahead and recompile without the logic for our first function that adds 2 numbers together. And we have new binary here, which, yep. And then we can go ahead and try and do the same thing that we did before, and it complains because it's not aware of that, because in our new compiled target executable, that function was no longer incorporated. So in the upcoming videos, I'll go through the pieces of this that, we basically have a parser, which goes and reads the tokens in this. We then construct an abstract syntax tree in this file, and then finally we emit WebAssembly binary format as we traverse our abstract syntax tree. So I'll be going through each of those steps in the upcoming videos, and yeah, looking forward to it. Thanks.